Okay, what we want to do here today is find an exact value for sine of 75 degrees. Now I did one a little while, I think I did tan of 15 a little while back. I've done a bunch of these. I did like tan of 9, but that was a couple years ago. So there's a few different ways to go about it. Now when we get this value, I think we're going to be able to also easily get some other values, but we'll start with this. And first of all, what we can do, the strategy usually is to get some values that you know, like we're not that familiar with what happens at 75 degrees, but we know about sine at 45, and we know sine at 30. I'm gonna drop the degrees just because I'm lazy. And keep in mind, of course, I could write this as pi over 4 plus pi over 6. Sometimes it just seems like maybe it's easier to use degrees when we have these angles we're less familiar with. I don't know, sometimes it's okay. It's just kind of a coin flip sometimes. So for this, we can use the different angle formula for sine. So what we can do is do sine 45 cosine 30, just using the formula on this. And then the second part, we just have to swap the angle. So it's going to be sine 30 cosine 45. But now we have a bunch of values that we know because our sine 45 and cosine 45 is the same thing. It's 1 over square root of 2. Cosine 30 is square root of 3 over 2, and this one is 1/2. So adding everything up, what we have, let's see, the first part's going to be just square root of 3 over 2 square root of 2, plus that's just going to be 1 over 2 square root of 2. So putting it together for sine 75, we have square root of 3 plus 1 over 2 square root of 2, and that's it. Now you could rationalize it. I think let's just leave it for now. Maybe I'll come back and rewrite it a different way, but we'll leave it for now. So now that we have this, another way to get to another useful value. Now we have our complementary angle formula for cosine, let's say. So if we have cosine pi over 2 minus x, this is the same thing as sine of x. Of course, pi over 2, that's just 90 degrees. So for sine of x, if sine is 75 degrees, we can say sine of 75 is just going to be cosine of 90, plug in 75 there, and we have this, but we can simplify that. And so for cosine of 15, we have this same thing here. So then with these two values, what I might like to do is find tangent, right? But I don't have cosine of 75. If I want a tangent of 75, we need sine of 75 over cosine 75, and we don't have the sine of 15. Well, then let's go find the sine of 15, but this time, and just notice that we could do like the same method, but that would be kind of repetitive. So let's do a different method. I don't know all the methods, but sometimes people are like, this way's a million times better, but like, I don't really care. I just do all the methods. So let's do all the methods, or all the methods I can think of right now. What we can use is the half angle formula for sine. So half angle formula for sine is going to be plus or minus the square root of 1/2, 1 minus cosine of x. You will notice this is just a rearrangement of like our power reduction. If you have sine squared and you want to reduce the power, you get 1/2, 1 plus cosine 2x. So it's just like we inputted, instead of 2x, we have an x here. It's just a manipulation of that. So we can go right to this formula. For sine of 15, we could write 15 as 30 over 2, right? And then our x value is going to be 30. And so plugging in, we're going to plus or minus square root 1/2, 1 minus cosine of x, which is 30. So this here is cosine 30. But now plus or minus, I'm just going to drop that. This is in the first quadrant, right? 15 degrees in our circle, right? That's going to be somewhere over here. So clearly positive. Then go ahead and reduce this. Cosine of 30, I think we did that over there. That's square root of 3 over 2. So what we're going to have is square root 1/2, 1 minus square root of 3 over 2. I guess we could simplify this a few different ways. I think let's get a common denominator right here. So let's see, we'll do it carefully. This is going to be 2 minus square root of 3 all over 2. I can break this up, like I can write it as square root 2 minus square root of 3, and then in the denominator we can write it as square root of 4, but square root of 4 is just 2, so what we have here, 2 minus square root of 3. but I don't really like it that way. Let's kind of do it. Let's do this a little differently. What I can do instead here, what if I multiply in, I'll multiply in, instead of stopping, let's multiply in 2 over 2 on here. So then doing it that way, what's going to happen, we're going to have 4 minus 2 square root of 3 over 8. And then that way, 4 minus 2 square root of 3, we'll just do it quick. This is the same thing as square root of 3 minus 1 squared. Just distribute that out and you get this, but it's inside the square root. So we can kind of boil this whole thing down to square root of 3 minus 1. And then square root of 8 is going to be the same thing as 2 square root of 2. I think that's a little bit better. So that's pretty nice. Let me fill that into our little table and put it back over here for sine 15. And then from here, we can do the same thing we did over here. We can just do complementary angle formula again. Sine, basically, I mean, it's the same thing, but like, we'll just write it out. So sine pi over 2 minus x equals cosine of x. So for cosine, so what I'm saying is for cosine 75, if this is 90, we plug in 15. Does this make any sense? So using this with the x value equal to 75 on this, then we're saying sine of 15 is going to be cosine of 75, and that's going to be the exact same value. So cosine 75 square root of 3 minus 1 over 2 square root of 2. So now we can go ahead and we can calculate our tangent values for 15 and for 75. So for tan at 15 degrees, we want sine of 15 over cosine of 15. So we're going to have square root of 3 minus 1. Here, I'll save a step and we'll do it as 2 square root of 2. So then if this is in the denominator, I'll flip it. We'll bring 2 square root of 2 into the numerator over square root of 3 plus 1. Then that way all this is going to cancel out. Then multiply by the conjugate here. So we'll multiply by square root of 3 minus 1, numerator and denominator. Then in the numerator, just multiplying it all the way out, we're going to get 3 minus 2 square root of 3 minus 1 plus 1. And then in the denominator, it's like a difference of squares. You're going to get a 3 squaring that minus 1. Put this together, we're going to have 4 minus 2 square root of 3 over 2. Divide into 2, and what we have for our solution of this, 2 minus square root of 3. I think this is the value we found in the previous video. Okay, let's see if we have room for cosine 75 really quick. Okay, now to finish it up, we just want tan of 75, but I think we have a shortcut for this so we don't have to divide it out. Not that dividing it out's that hard, but let's just do this. Tan of 15, if we did the complementary angle formula on it, we would get back cotangent of 75. Just doing the same thing we did over here with sine and cosine, putting it together. This value is going to be the same thing as cotangent of 75. But tangent is going to be just 1 over cotangent of 75. Those are reciprocals. So we can just take the reciprocal of this and calculate 1 over 2 minus square root of 3. But then using the conjugate, right? Multiplying in like this. Well, we're going to have 2 plus square root of 3. Multiply this out. We're going to have 4 for the first term minus 3, but that's just a 1. So our value for tan of 75 is going to be just 2 plus square root of 3, and that's it. Okay, so there you go. All the trig functions for 75 and 15 degrees. Of course, you can get secant and cosecant as well, just taking reciprocals of the sine and cosine functions. Okay, that's it for today. Thanks so much for watching. Have a good day.